Hey, hello everyone. Today is another series of the most frequently asked examination questions. So today the focus is still focusing on Arene chemistry for H2 chemistry GCE A-level exam. So let's take a look at some of the questions that they like to ask. So the first set of questions I talk about is the year 2006. Let me just highlight 2006 paper 3 question number 8. Alright, this is paper 3 question number 8. So in the past there's more questions, they need to choose more. So this is a very old set of questions. So let's take a look together. Methylbenzene is useful starting material for the synthesis of many intermediate used for your pharmaceutical dyes and agricultural chemicals. Now, suggest the reagent and condition needed for each of the reaction 1, 2, 3, and 4 in the following scheme. So number 1 here. So let's take a look how we tackle this kind of questions. First thing, you must know that how many different types of hydrogen are actually present in the reaction. So there are two types. One, let me draw down. This is 1 because this hydrogen is belong to the benzene ring. You see this H belong to the benzene ring. There's another H here. This belong to the side chain. Okay, they are very different set of carbon. This is a side chain version. This is the benzene version. Okay, so for benzene, you normally need a catalyst for reactions. Side chain, no, you don't need because side chain is like an alkane group here. Alright, so the first reaction here, take place on where? On your side chain. If you take place on side chain, so alkane, okay, the side chain is the alkane. So you ask yourself, what's one of the reaction that alkane here actually undergo? Did you remember? Alright, I hope you remember. So let me write down. Number 1 is actually your free radical substitution reaction. Okay, so let me write down the name first. Free radical sub. And my abbreviation for free radical sub is FRS. Then followed by, I know that the reagent condition should be Cl2 gaseous, but don't forget you only one Cl, so you'll be limited. Then followed by, you will use UV light. Okay, UV light. This is number 1. So basically done. Second, now if you take a look at the reaction here, this one will take place on the side chain. Okay, free radical sub. Now, if you take a look at part 2 or the second part, where is the next reaction taking place for the Cl substitution? Take place on the benzene ring, you see, on this position. Okay, so do not get too worried about how come you substitute here instead of here. It doesn't matter. Alright, the most important thing is that it's the hydrogen that is on the benzene ring. So any reaction that takes place on the benzene ring, especially something substituted, it is called what we call the electrophilic substitution reaction. So it's called ES, electrophilic substitution reaction. Now then, for electrophilic substitution reaction, what is the reagent and conditions? So for electrophilic substitution reaction, normally you need a catalyst for the reaction to take place because the reaction don't take place that easily. So which means that I'll be using a catalyst AlCl3 solid. Okay, it's very important to stress solid, or you can at least write down is the word anhydrous. Okay, it must be dry, very, very important to stress on solid or anhydrous. Then after that, you will use the reagent because you need a catalyst, you need a reagent. Got catalyst, no reagent cannot work. So you Cl2 in CCl4 under room temperature pressure. So you do electrophilic sub. So basically the reaction can take place easily. Alright, got the idea? Alright, good. So this is how the reaction takes place. Then you move on to the next part. So the next part here is methylbenzene convert to become a carboxylic acid. So how does this reaction being carried out? Very simple. First of all, where does the reaction take place? It's on the side chain. Okay, side chain is very different for the benzene ring. Remember I said before, on the benzene ring, you need a catalyst. So that means the side chain, not necessarily need a catalyst. Now, how do I know what kind of reaction is this? This is like hydrogen. Hydrogen is removed to add oxygen. When you remove hydrogen, you add oxygen. The name of this reaction is called your oxidation, but it's depending on the side chain, so we call it as side chain oxidation. Some of you all may learn it as oxidation reaction, but we call it side chain oxidation reaction. Then after that, we can write down the reagent and condition. So right now the common use oxidizing agent. So one of the most frequently used oxidizing agent is your KMNO4 aqueous. Then of course it's normally in the acidic version, so you must write down H2SO4 aqueous. Then this reaction, because you need to break the CH bond, not so easy to break as CH is very strong, so you need heat under reflux. Alright, so this is the reaction for part 3. Now we move on to part number 4. So for part number 4 here, what do you notice? Where does the reaction take place here? It's on the side chain again. Okay, side chain again, different. So this is a side chain from here to become a Cl. So now you are going to change the group to become a Cl. So first thing first, we must analyze what is this group here. This is called your carboxylic acid. So let me draw C double bond O and OH. And they're going to change this carboxylic acid to become a acyl chloride. So which means they want to change the OH to become a Cl. So as a general rule to remember, every time you want to change the OH to become a Cl, this is like changing alcohol group. Okay, I know it's carboxylic acid, but just remember OH to become a Cl, the strategy is always the same. There are some exceptions, but for now, this will always work. Yeah, part 4, because it's exchanging, we call it as nucleophilic substitution reaction, because you need a nucleophile to drive the reactions. So which means that this reaction here, you will use PCl5 solid under room temperature pressure. So let me stress, you need PCl5 under solid. The solid symbol must be there. So this PCl5 will exchange the OH to become a Cl group. Right, so this is a nucleophilic substitution reaction. Then from here, you basically complete all the reagent and conditions for part 1, 2, 3, and 4. Right, so make sure you rewatch again if you need to clarify some of the doubts. Let's take a look at part B together. Now for part number B, explain the relative ease of hydrolysis of the chloro of H, J, and K. So right now we are comparing H, J, and K here. So they are totally different types, right, of your chloride. So let me explain to you. So basically your H here is your what we call CCl group. Okay, normal CCl group, alkane alkyl chloride. Then the next one is J. J is different. J is chlorobenzene. Then followed by your K here is called your acyl chloride version. Now the rule to remember is acyl chloride will be the easiest to be broken apart. Now why is it easier to be broken apart? Because it's pulled by two very electronegative atoms. So therefore this carbon here is very delta positive. Okay, very electron deficient. So therefore it facilitates the nucleophile to attack. So which means you have a nucleophile here. The nucleophile is a negative charge, can be very easily attracted towards a positive, so faster rate of reaction. Now if you take a look, K is the fastest because you have 2 electron withdrawing group. Then this brings attention to your H. Your H only have 1 electronegative atom. So only pull once. So it's less delta plus, the reaction is a bit slower than your K. The last one, which means the slowest in reactivity, is your J here. Now why J is the slowest in terms of its reactivity? And this is something that you will learn in a chapter called halogen derivatives. You have not learned yet, do not worry, follow me on this one. The lone pair here. So every time you will see a lone pair that's attached or very adjacent directly to the benzene ring. Okay, there's a lone pair, there's a benzene ring here. This lone pair will delocalize directly right to the benzene ring. Okay, so the benzene ring like electron, so it will cause the lone pair of electron Cl to delocalize to the benzene ring. So this process of delocalization will cause a partial double bond to be formed. So you see, this one is single bond. Single bond, this is partial double bond. Which one do you think is stronger? Of course, your J is going to be stronger. That's why J is the slowest rate of reaction. Hence, if you want to write in terms of the order of reactivity, I would say that your K should be the fastest, then followed by your H, then finally is your J. Right? Very important to remember this trend. Now let's take a look at C part 1. Now for C part 1, explain the meaning of the term of electrophile. So you can say that it's an electron deficient center. Right? So this is what I mean by electrophile. Now let's take a look further on part 2. Suggest how Cl plus is formed from the reagents in reaction 2 that you mentioned in part A. Let's take a look here. So they say that they want to form the electrophile Cl+. That's why the Cl can be attached to the benzene ring. So how do we explain it? Oh, very simple. You can say that your Cl2 will react in the presence of AlCl3 to form an electrophile. And what's the reason behind that? Because AlCl3 is a Lewis acid. That accept a pair of electrons from Cl2. Right, so this is the explanation to talk about part 2. Then let's take a look at part 3. Suggest the mechanism of the reaction of the electrophile with methylbenzene. So whenever you see the word suggest mechanism, it simply means that they want you to write down the mechanism to break down how the reaction is being carried out. So for electrophilic substitution reaction, there are total of 3 steps. So whenever they ask you to suggest the mechanism, make sure you write the name. You should remember if this reaction is taking place on the benzene ring, what do we call it as? We call it as electrophilic substitution reaction. So the name here, always remember, spell the full thing, but now I'm just going to abbreviate it, electrophilic sub. So there are 3-part process. First part is your formation of electrophile. So you have Cl2 reacted with AlCl3 to form Cl plus and AlCl4 minus. Second part, you have a methylbenzene CH3 react with Cl positive, so this nucleophile will attack the Cl plus, and this is a very slow step because it involves in bond breaking, so it's slow. Then you form your intermediate. So right now it's at the 4th position, so it will be consistent. So CH3. Then you draw the H, then you draw the Cl. Alright, so let me stress, your surrounding phase here, you see now is the inverted version. So this position, right, is always in the direction of where the substitution take place. If it takes place on the 4, you will put here. If it take place here, you make sure it's small in this direction. Okay, a bit different direction. Now we take a look at part number 3. So the third step. The third step is to make sure you close the ring. So how do you close the ring? So you draw the intermediate. So you have a CH3. Then you have this. Then you have a Cl. Then you have a H. Then you react with AlCl4 minus. And this one here is different color. You attack the H. Go back to the ring. Then finally, this is a fast step. Okay, because they want to quickly form stable compound as minus a plus is not so stable. So they form your final product. So you form the final product here. You form CH3. Then you form your Cl. Then after that, you regenerate back your catalyst because, as we mentioned, AlCl3 is a catalyst. Catalyst is able to be regenerated. Then you form your HCl. Alright, good. So this complete, right, the videos on one of the most frequently asked questions in Arenes. So thumbs up if you like it. Then make sure you comment below, like for example, some of the key chapters, right, or key problems that you face. Then we'll create the videos for you to see, to understand the concept. Then remember, we are always here to help. So I hope you enjoyed the video and see you next time.